All right, well, thanks everyone for attending today for PTV's first spotlight. Excited to present today with Ben, and we'll be talking about a citywide Vistro model that we put together for the city of Dickinson. This was a project that came up with City of Dickinson looking to update their metropolitan transportation plan, as well as a master transportation plan for the area, really addressing very dramatic growth within the area. So just for a little bit of context, Dickinson's a city in southwestern North Dakota. It is along Interstate I-94, which connects Dickinson to other cities in North Dakota like Bismarck and out east to Fargo. It also has some connections west into Montana as well. Really, Dickinson has a lot of energy-related industry in and around the city. During the mid-2010s, the oil boom in North Dakota significantly swelled the population within Dickinson, and it had since kind of evened out. But with the last comprehensive plan that Dickinson put together, they really overshot the growth expectations for Dickinson. So with this comp plan, we really wanted to look at more of a measured approach and specifically development-based forecasting for this model so that we could better react to specific developments and what those developments would cause for roadway growth. So Dickinson has seen about a 35% growth in that 2010 to 2020 timeframe. The software that we were looking to use for this study was really a combination of Streetlight and Vistro. We wanted to use software first off that we had access to Streetlight, looking at volumes, and then PTV Vistro. We've used that for a lot of studies in the past. And even though this was a very large scale model that we were putting together, we felt that that was a good tool to represent the demand that we were looking for as far as effort going into this study. So looking at Dickinson, it really does have its main downtown on that business loop, Highway 10, going into the southern part of the city. Most of the commercial is along this business loop coming in and out of the city to Interstate I-94, as well as a lot of residential in the other locations. The locations between 94 and 10 have seen a lot of kind of older single-family residential, but the city has really put a focus on looking at medium density or higher density housing to help support the growth over time. Goal for the modeling process was really understanding the existing origin and destination characteristics of the town, really going from that residential to commercial, a lot of those trips staying within Dickinson, so people working and living in Dickinson. We also wanted to be able to quickly look at different development scenarios, comparing that high density residential with lower density residential assumptions. And then lastly, we wanted those forecasts leading into intersection level results that the city could use to look at the capacity at those intersections and quickly look at alternative intersection options. So I talked a little bit about the historic population trends. You can really see from the 20s through the 80s, there was kind of sustained growth in Dickinson between 1980 and 2010. That growth really flattened out. And then in that last decade, it really started shooting up again with its population. based on that last oil boom. We wanted to really have a flexible model so that we could look at several scenarios of kind of that high level growth coming out of the 2020s into 2030 and 2040, as well as more of a moderate growth scenarios. So we actually looked at some of the previous population estimations from the 2013 work on the last LRTP. This had a lot of that growth built in between 2015 to 2020 that just wasn't realized. So we really wanted our future forecast with this project to kind of look at that trend line continuing, but also understanding that the population within Dickinson can jump at any time if energy and oil related activity picks up. So as we started laying out our study boundaries, we looked at the current municipal boundary and really looked at where additional development pressures were in the city of Dickinson. That urban service boundary was expanded out to capture a few parcels that we're looking at future development in the next 10 to 20 years. Increasing that demand for housing. Dickinson has a kind of documented shortage of housing for the commercial and industrial uses within the city, and it's really been a key spotlight for the city in its comprehensive planning is to really raise the housing within the city. So just looking at where that housing is today, you can see that a lot of that kind of 20 to 60-year-old housing between I-94 and business I-94 is primarily single-family housing. On the north side of 94, where more recent developments have been added, it's been a mixture of single-family as well as apartments that have 10 plus units. And then also on the western side, this is more commercial today, but there has been some demand for other single family housing towards kind of the boundary of the urban area. One key part of the plan was also looking at multimodal gaps throughout the city. I think this map helps stakeholders really address where there were parks today and schools and other pedestrian focused uses. And you can see from this map, there are a lot of those gaps between schools, residential, and parks that needed to be addressed with this future transportation planning. Lastly, Dickinson is set up a little different than other cities and other states where almost all of the collector roadways within the municipal boundaries are owned by the city, while county roadways are primarily outside of those municipal bounds in the kind of municipal planning area. So this was a little bit different than some of the studies we've done in Minnesota, where really working with the city on those kind of main roadways within the municipal boundaries, but then also looking at the study area and integrating county decisions in the kind of township roadways outside of those municipal bounds. Really the recommendations focused in that urban area for municipal and state connections, but the county still had some input into around the airport there on the south and some development around there, as well as connections into the state system at I-94, especially on the western side of town, where North Dakota 22 comes off to the north. and that county connection to the south. Going on to functional classification, we looked at really capturing all of the arterials and collectors in our modeling. We wanted to have decisions on these roadways where capacity could become constrained in the future, and wanted to make sure our model matched that level of sensitivity from the plans that the city had put together in past LRTPs. It's a very dense collector network downtown, so that's the zoomed in image there. You can see that it's almost every block is a collector. So we really had to key in on not having those connections in our Vistro model between every roadway, so that we could prioritize where existing routes were accessing each of those blocks today. And then with our future development, really matching those considerations. We also looked at capping our analysis for these roadways, anything less than 1,000 daily trips. We did end up kind of cutting those intersections out of the model in just a way to kind of simplify this process of looking at 100+ intersections. So with that, I'll turn it over to Ben to talk more about how we developed our volumes for this analysis.
Thanks, Joe. So we've heard a little bit about some of the background on Dickinson and a couple of the problems that they're dealing with currently. So when looking at the volumes, it was really important that we had enough volumes to make a working model. But like Joe said, we did have that cap of 1,000 vehicles to make sure our model didn't get too complicated, making sure we had the right macroscopic view of things. So we did get volumes from streetlight data, and we did compare those to the existing North Dakota Department of Transportation published counts that they have on their website. Those were ADT forms, whereas we had turning movement counts that we then aggregated into ADTs to compare. But in terms of the streetlight data, we did start with the census block groups that Streetlight does provide in their common analysis tools. And like Joe mentioned, we did divide further, reducing the roads just to analyze the arterials and connectors. And you can see the traffic analysis zones that we ended up with there on the right-hand side through most of downtown, and then up through the North Dakota 22 bypass. And then on the next slide, we can see what that looked like in Streetlight once we did break up all these analysis zones by arterials and collectors. Those traffic analysis zones, I believe there were about 105 to 110. We kind of wanted this similar to the land use map, where we're able to see where this residential but also commercial and industrial balance was. So taking a look at existing origin destination pairings was very important in this study. We did use this to create an origin destination matrix for all of these zones. And what we did with that was we were able to look at the entering and exiting vehicles of each traffic analysis zone. And we did end up getting the percentage of those. And as you can see on the figure to the right, the total exiting to other zones and the total entering in each zone. So you can see a lot of trips happening in that downtown area, and even in that north side where maybe you wouldn't expect that as much. But this is sort of what we looked at for our homework percentages. And this origin destination continued into our forecast analysis once we weighted in the future projected trips that we were going to have as well. So we also did a top routes analysis from Streetlight. This was important to take a look at some of our growth rates, as well as understanding the directionality along the major exterior roadways, those highways we've mentioned, I-94 going to Bismarck and into Montana, and then also North Dakota 22, which runs north and south as well. One important thing to note about this corridor is just the sheer amount of trucks. I-94 throughout Dickinson has about a 25% heavy vehicle percentage, so it was very important to understand these truck movements, especially how they could get off of the main freeways and highways and get into downtown as well. And so not only did we do origin destination, we also grabbed turning movement counts, which we would then input into the Vistro model. And then looking at forecasting, we did apply the origin destination percentages for each zone as well, and then adjusted those turning movement counts with the change in land use through ITE trip gen, depending on the land uses that we got. And that's sort of how we came up with our forecast condition for this project. But looking back at existing, as I mentioned, we did get those 24-hour counts from Streetlight, averaging those approaches between intersections to get AADTs. And then we did look to validate that with North Dakota's AADTs. And something to note here, that's a Streetlight specific thing. Before every project, we compare the 2021 location-based data that Streetlight has with the 2022 connected vehicle data that Streetlight has with the counts we're working with, so we can get a more balanced set of data from the start rather than having to make adjustments further on. So that figure on the bottom left, comparing 2021, 2022 Streetlight data along with the North Dakota AADTs. The 2022 data just represented the area much better. Some were higher, some were lower, some were right on even, whereas 2021, most of our values were a little short of what we were hoping for. So we ended up using 2022 data for this project. Just the raw data compared to North Dakota AADTs, we ended up with a 0.97 R-squared value. Of course, a couple more decimal points on there, but for consistency, 0.97. After we validated that Streetlight data and adjusted a little bit with some weighted averages throughout the corridor, we did end up with an R-squared value of 0.99. So definitely fit much better and allows us to have accurate values moving forward that we could then input into the model. And so looking at the travel demand model process, this is where I'll talk a little bit about the trip generation and trip assignment. First off, we did have a discussion internally over what software we were going to use. We wanted a macroscopic model, which both softwares do. They also let you do OpenStreetMaps import to simplify the process of creating the model as well. And we did have Vistro, so that definitely came into account. VZoom is great for travel demand models, and that's the focus. But in this case, the client really wanted to know where vehicles could break down more than just volume over capacity. So we chose to use Vistro, which was scenario-based, and that we could incorporate trip gen and routing into. So that is why we chose Vistro. And so after we imported the maps, did all our adjustments to lane configuration, deleting the intersections where there wasn't 1000 ADT, we did end up with I believe it was about 180 intersections. Have all the ramps, of course, to the highways and towards downtown, more towards Villard I-94 business. You can see that downtown area as well. Most of those connections also along North Dakota 22, having all the signals on that corridor as well. So that's a little look at the Vistro model. And so once we were comfortable with our volume set, we did bring that into Vistro and then balanced our zones with our in and out distribution that we mimicked from the existing conditions. And then once we did balance these, we did see that there was a 95% balanced peak condition, which was very helpful to see, knowing that our data matched well with the model. And so we did use ITE trip generation for our trip generation, and this was based on our land use and then the factor that was in the area for AM and PM trips and also daily. So we did import and export from Vistro to apply each of these trips to a specific zone, and that matched up with our traffic analysis zone data. We had one for each zone where we had in and out trips that were generated along with in and out percentages that we had from the existing model. And then we did factor this trip generation to match population and employment growth. And one of the ways we did this was by using multiple different scenarios that we compared. So we had 3 scenarios that our transportation planning team got us with different acreage for each land use in each zone. So scenario A did not meet the employment needs of the city, which we see currently in the city. So you can see that in Trip Gen A, along the regional roadways, we had to add a lot more vehicles going into the city in the AM and leaving the city in the PM, which implies that the employment needs were not met. We saw the opposite of this in scenario C, which caused residents to leave the city to find employment. So you can see in Trip Gen C, the regional roadways, you can see a lot more leaving than are coming in. So scenario B was the middle ground where we met the employment demand in the city while also not flooding the residential in a way where a lot of trips would have to leave. And something I should mention is we did apply a 1.4% growth rate to the regional roadways over time, as the land use doesn't necessarily change on a highway. So to get that to a future condition, we did just do a growth rate. And then to balance the model as a whole with in and out vehicles in AM and PM, we applied a percentage that would be coming in and out of the city throughout each AM and PM peak. So scenario B was the one we ended up going with. You can see the difference in trips generated daily for each scenario. Trip Gen A was 25,000 right about. Trip Gen B was 31,000, with Trip Gen C being more 37,500. Joe and I were comfortable with what scenario B presented, so we moved forward with that scenario. And so once we had the trip generation, we had to assign these trips to each zone. So what we did was we had a spreadsheet where through multiple iterations, we were able to sort of match how many trips should be coming from a zone to what currently is. So we continually added vehicles until that difference was very small. So we combined the existing distribution with these volumes to apply the growth throughout the metropolitan area. And so what we ended up with from that matrix was having origin and destination percentages from the other zones. And we did import this into Vistro for each zone, these percentages. So from percentages and to percentages. And then the trip paths are automatically created based on the shortest path. So it was a quick check to make sure that those looked right. And they actually all did, which was super impressive and really helped with our project. And so now I'm going to hand it back over to Joe for some of our results.
Thanks, Ben. So just furthering on some of the discussion with shortest path, we really did pay attention in our model to really limit those cut through segments by actually breaking those roadway links in strategic positions, knowing that Vistro is kind of that shortest path calculation for trip assignment. So a lot of that early work in that model creation really simplified the forecasting process because those longer trips did stay on arterial connections moving through the network up until those collector roadways that connected them into their final destination. Another big benefit of Vistro was just the ability to copy spreadsheets in and out of the model. We did this for volumes as well as the MOE results that we had for our intersections. So these were an easy export out of each of our models. We had the existing AM, PM, our future scenario models, as well as our mitigation models that we were very easily able to export them out by our IDs. Our IDs were set up in a way, a 4-digit number, where the first 2 digits were the north-south location in the city, so 10 being the southernmost, 90 being the northernmost. And we were able to keep arterial corridors consistent through those numbering schemes. The second 2 digits were from west to east. Similarly, kind of keeping corridors consistent but spaced out, where if it was a number lower than 50, it was to the west. If it was a number higher than 50, it was to the east of State Street, which was that kind of middle north-south connector through the study area. Being able to export out these tables made it very easy for integration into GIS, where we created intersection points based on those ID numbers and could easily reference in the level of service and delay into GIS figures, which you can see on this screen. It allowed us to have a kind of map format similar to other information we were presenting to the City of Dickinson, and had it very optimized in being able to export results or modify results and export out a new set of results for the city to look at and comment on. So for our results, we are able to export out that traffic control, whether it was a signalized or unsignalized intersection, the level of service results, and came up with an initial list of deficient intersections. We were able to identify where there were queuing concerns, especially around the I-94 interchange on State Street. While the level of service was acceptable for those intersections, just having that visual model to identify where those queue lengths could become an issue in future results allowed us to better plan for improvements and access considerations in those areas. One limitation of the Vistro model that we found was the ability to look at VMT and VHT from a network-wide basis. We looked at exporting the Vistro model into vSim to look at kind of those network results. We could have gone to vZoom as well, and kind of looked at that strategy with PTV. But just in our overall comfortness with Vistro and vSim, we were able to kind of export the model into vSim. We did update always stop configurations within the model, as those were creating node results that were above, quite above what was coming out of Vistro for delay. So we were able to kind of calibrate the always stop intersections to match, while the two-way stop and signalized intersections were coming out with pretty similar results on an intersection basis to Vistro. This allowed us to then calculate those network statistics of VHT and VMT that we wanted to compare between existing and future scenarios for our long-range transportation plan. As we started looking at our 2050 results, we were really able to identify where developments were putting strains on those I-94 interchanges. And we were actually surprised that the capacity of the Business 94 loop going into downtown was still operating at level of service C or D for most of those intersections. So we were able to really hone in on those corridors and interchange locations that were showing deficiencies that we could talk through with the city and understand some of those development thresholds that would cause these traffic conditions where those intersection operations were breaking down. And then also utilizing our GIS group to overlay that development growth with the level of service results for the city to really understand the magnitude of the developments that were causing roadway deficiencies throughout the network. So going through kind of a lessons learned for this project, we really found that it was a very efficient way for us to look at a metro-wide operations based on limited data coming in. The entire process of the Vistro model and streetlight data probably took about 2 to 3 weeks to put together from an hours standpoint. So it was very easy utilizing OpenStreetMaps to import in that base model of intersections, really going through numbering them in a succinct way that we could do quality checks more efficiently and get that base model set. Utilizing streetlight data, we were able to mimic that existing origin destination demand as a start for our future forecasts. So understanding what percentage of traffic from zone 96 to zone 60 was occurring in existing conditions, but we also were able to use our spreadsheet process to really look at magnitude increases as well, where if TAZ 96 was adding 100 residential trips, zone 60 was adding 100 industrial or commercial trips. There was more percentage of those housing to commercial trips going in that new development versus just the proximity basis that was in the existing origin destination demand. So we were able to kind of balance both of those biases within our future forecasts. It was an iterative distribution for that future origin destination usage, with looking at the regional roadways versus the trip generation within the municipality. So Ben did a good job kind of explaining between scenario A, B, and C, how we were looking at that balance of low density or high density residential with the amount of commercial development that Dickinson was looking at adding, and making sure that those balanced in that long-term forecast, so that they could keep both residents and jobs within the city boundaries. And then lastly, being able to export out those AM and PM volumes from Vistro for those future development-based forecasts. We could also develop our future ADTs off those projections, using existing peak percentage of daily to then factor those back to daily estimates for our network. Being able to also kind of sum up all of these inputs on a metro-wide basis for trip generation, we were able to go back to what those population estimates would be based on the residential growth, and really help Dickinson understand that if it was seeing a big change in population, similar to the 2010s to 2020s, that's where high density residential would help support that growth a lot more, such as scenario C. And then for scenario A, that was a much lower density residential, which would be more of that sustained growth. But understanding that, you know, it would really need growth outside of the city to support the commercial and industrial growth of jobs that the city was projecting. So it allowed us to really get into those detailed conversations with the client on those topics, and give them a detailed metropolitan transportation plan moving forward. So with that, I'll open it up to any questions that have come through, and here's our contact information. If you do have questions on this study, I'm always willing to share any lessons learned and feedback with anyone who's interested. Thank you.